See, the common instructions to each one of you is, even though we are on the online mode, and if somebody is coming to the college for some like a scholarship or some official works, so they can come to me and we'll sit together, huh? No issue. But if you wish to come over here, then otherwise you can enjoy the lecture from home. So we are here. This is our unit number 3. And the name of that unit is Bending Stresses, Loop and Deflection. The complete unit is basically based on this formula. This formula is known as the bending formula, or this formula is called as the flexural formula. So the formula is m by I is equals to sigma by y is equals to v by r. And we have to use this formula in order to calculate maximum moment, moment of inertia, bending stress, distance of any layer. Sometimes we are going to go for the elastic constant calculations too, if it is not given and if it is asked. So we have given some basic sections: circular section, hollow section, rectangle section, T section, and I section. Okay, so just go through the slides. I'll going to give you the highlights. So this is the beam which is subjected to the both end of support, which is simply supported beam, and this is one type of the beam which is the cantilever beam, which has one end is fixed and other end is free. When it bent, there is a deformation like this way. Accordingly, there is a compression at the top layer and the tension at the bottom layer observed. And exactly opposite to that, in the cantilever beam is observed. So these are some assumptions, but we have seen these assumptions. What the important for you is, this formula is very important for you. The terminology of that formula and the different units of this term. This is very important slide. The slide is very useful for the examination point of view, oral point of view, as well as MCQ examination point of view, as well as if there is a theory examination. In that case, you need this formula too. So very important formula and very important units. Am I audible to each one of you now? It should not happen that I am just telling you something and you're sitting and enjoying something different over there. Am I audible? Just give me.
Yes, sir.
Okay, my screen is completely visible to each one of you now.
Yes, sir.
Okay. So these are the formula: m by I is equal to sigma by y is equal to e by r. Actually, those students came for the offline classes now. They are very much familiar with this formula and they know the importance of that formula. है ना कल्याणी? कल्याणी.
Yes, sir.
Okay. Okay.
Yes, sir.
Kalyani, what is this y? What is this y? Y is what?
Fiber stays at a distance y from the
The what?
nature axis mm.
Nature axis. This is nature axis, neutral axis. That should be the neutral axis. Okay.
Sure,
Yeah,
sure,
nahi.
sure.
So you missed something. Huh? So this is the y, the distance of any ray from the neutral axis, that is NA. So we have solved many numericals based on this. So after that, we have seen the nature of bending. Then we have seen the possible expressions. We have seen a derivation. Then we come to know and we discuss about what is CG, that is center of axis or center of gravity. Then what is centroid, that we have studied. Then we studied about the location of CG, X bar and Y bar. Then we have studied the CG for different section, that is square section, that is rectangle section, that is triangle section. The CG is like that X bar is equals to B and B by 2 and D by 2 for rectangle section, and for B by 2 and D by 2 for square section. Then it is H by 3 for the triangular section. Then for circular section it is D by 2 for semicircle. So I have given all the formulas to the students. What is we have already discussed what is CG, what is parallel axis theorem. This is principal moment of area, that is second moment of inertia. We have already discussed about the second moment of inertia. What is Ixx, what is Iyy. This is first moment of inertia. This is first moment of inertia. Then the moment of inertia is the second moment of inertia, that is ay square plus a2y square and so on. Or ay is basically moment of inertia is the second moment of inertia. Okay, so we have seen the parallel axis theorem. So Rutuja, if here it is Rutuja, Divya is there. Okay, Nikam or Rushikesh. This is a parallel axis theorem, and here it is IAB is equals to IG plus AH square. So what does that IAB stands for? Whether it is IXX or IYY or what is this?
IX6.
Perfectly correct. This is Ixx is equals to Ig plus A1 H1 square. Correct. This is the parallel axis theorem that we have discussed in the classroom. Then we went for perpendicular axis theorem, that is Iz is equals to Ixx plus Iyy. Izz is nothing but the polar moment of inertia. Nikam, how do you represent polar moment of inertia? What is the sign convention for the polar moment of inertia? I, Ixx, Iyy, Z or J? Nikam, Rutuja. Rutuja is there, Rutuja Gangude. Am I audible to you? So polar moment of inertia is represented by Ixx, Iyy, Izz, J or I. Which term is correct? Rutuja Gangude. Pratik Nikam. Rushikesh.
J, sir.
Very good. J is a polar moment of inertia, right? Then this is a short derivation for that bending formula or flexural formula. Ixx, Iyy, Yc, Yt, Ymax. So this is very important slide. Rushikesh, Nikam, and everybody. This is please have a screenshot of this slide. This is the different maximum moment required for the different load conditions. During the numerical solutions, I told you that write something in the bracket. So the formula is when the simply supported beam is there with the point load at midpoint, at the mid span, the intensity of the maximum moment is WL by 4. For simply supported beam with the UDL over its entire span, the maximum moment will be WL square by 2 and so on. So this is the standard case. So you have to please have a screenshot of this slide or take a like what you want to have, but keep it with you. This very important. This is the important for MCQ's point of view, for examination point of view. Okay. Then moving on the next slide, which is Rushikesh. What is YC and what is YT? Rushikesh, what do you mean by YC and what do you mean by YT? Anybody? Chavan, Kalyani Chavan. Anybody? Can anybody tell me what is YC and what is YT? Anybody? This is sigma C and sigma T. What is sigma C and what is sigma T?
Sir,
हा बोला.
sigma B is equals to average bending stress.
सिग्मा बी कुठे आहे बेटा इथे? दिस इज सिग्मा सी and this is sigma t. Sigma c stands for what? Sigma
Compressive stress.
perfectly correct. This is the compressive stress and this is sigma t is a.
Tensile.
Then if this is compressive stress, this is tensile stress, what does yc and yt stands for? What is yc and yc stands? Yc and yt stands for? काय असणार आहे? It is a distance of extreme fiber in the compression zone. This is the distance of extreme fiber in the tension zone, Yc and Yt. So we have seen some basic numericals, but right now I'm not in the mood to repeat those numerical. But yesterday we have conducted one numerical which is pending. So I'm going to start this numerical. The numerical is those who have the first lecture, they can come to me and we will sit together, no issue. This is the numerical that we have studied yesterday. Right? So I ask everybody to find out the x bar and y bar. So can anybody tell me what is the x bar for this? This is the statement. Simply suppose this is the statement from the numerical which we have conducted in the last lecture. A simply supported beam with overhang as shown in the figure, allowable by bending stress and the compression stress are sigma t is equals to 150 MPa and sigma c is equals to 100 MPa. Find the safe load W on the overhang. So the geometry is given to us. This is the section and this is the loading diagram. Where it is the loading diagram is given to us. The loading diagram is given to us. This is the loading diagram. So they told us to identify the value of W. So when such a case comes into the picture, what we have to do? We have to follow a few steps. The step number one is Rutuja. What is step number one? Rutuja, Kalyani, Nikam, Rushikesh, Nilesh. What is the step number one?
X bar and Y bar.
Perfectly correct. So tell me what is X bar? How much X bar is for this? If you have any material for the studies numerical, please tell me how much X bar for this.
Sir, x bar is equals to 80 mm.
Very good. 160 by 2. Perfectly correct. My second question is how to calculate Y bar? Y bar is equals to
A1 Y1 plus A2 Y2 plus A3 Y3 divided by A1 plus A2 plus A3.
there is a 4 section. Very good. For section 1, 2, 3 and 4 section we have. So formula go up to A4 Y4 divided by A1 plus A2 plus A3 plus A4. Okay. So we have calculated the values for X bar and Y bar. And X bar, you just told me the value for X bar, it is 160 by 2, that is 80 mm. And the value for Y bar, it is, how much it is, Rushikesh? Yesterday you have calculated the values. So the centroid is 180, 160 by 2, that is 80. And to calculate Y bar, the formula is A1 Y1 plus A2 Y2. Those who are having first lecture, now don't worry about the session. You just listen out, everything is self-explanatory. Once you come to the college or once you have an issue, ping me, I'll explain you all routes, all two. Okay, so this is the formula. So from the different section, like this is section 1, 2, 3 and 4. I have to calculate A1, A2, A3, A4. So this is simple the area. So 30 into 160, 20 into 100 and 200 into 20 and 20 into 100. This is the areas. And what is Y1, Y2, Y3? So from baseline, 30 by 2 is a Y1. 30 plus 20 by 2 is a Y2. 30 plus 20 plus 200 by 2 is a Y3. 30 plus 20 plus 200 plus 20 by 10 is a 20 by 2 is a Y4. So we have identified the value of A1, A2, A3, A4 and Y1, Y2, Y3 and Y4. This calculations we have done in the last lecture. So the answer for X bar is equals to 80 mm and the Y bar is 99.37 mm. Okay. So these are the two first step to locate the CG. What is the second step? Anybody? What is the second step? 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 Rishikesh? Anybody? Chavan? Chavan? Am I audible to everybody or not? The second step is what? What is the second step?
Moment of inertia identification.
Very good. Moment of inertia, MI calculation. Very good. So MI calculation is the second step. So we have to calculate MI. MI calculation. So this is the section where we have to apply the parallel axis theorem. So Ixx is equals to Ixx1 plus Ixx2 plus Ixx3 plus Ixx4. So how to calculate Ixx1? Ixx1 is equals to Ixx1 is equals to Ig1 plus A1 H1 square. So Ig1 is equals to, it is a rectangular section, so it is BD cube by 12. Similarly, we have to calculate Ig2, Ig3 and Ig4. A1, A2, A3, A4 we have already calculated. What is the formula to calculate H1? H1, how to calculate H1? H1 is y bar minus y1. H2 is y bar minus y2. H3 is equals to y bar minus y3. H4 is equals to y bar minus y4. And we have to calculate the different Ixx1, Ixx2 and Ixx3. So in the last lecture, we have already calculated the value of Ixx1, Ixx2, Ixx1 we have calculated, Ixx2 we have calculated, Ixx3 we have calculated, and Ixx4 we have calculated. And from this, we can have the value of Ixx as a 116.89 into 10 raised to 3. Am I right? Am I right? Last time we have calculated the value of Ixx.
Yes, sir.
Okay, up till now it is right now. Shaha.
Yes, sir.
Okay, good. So once we have the value of moment, once we have the value of x bar, y bar, once we have the value of mi, then we have to look for to find. So they ask us to identify the value of w, and the diagram is given to us. This is the diagram is given to us, and they told us to identify the value of w. So for the calculation of this w, we have to calculate the RA and RB. So considering this is as overhang beam, and we have to take the we have to calculate RA and RB. So my question to each one of you is, if I wish to calculate moment at A and moment at C, what is the value? Moment at A is equals to how much and moment at C is equals to how much? Moment at A is equals to how much and moment at C is equals to how much? Free end. What is the intensity of movement at free end? Rishikesh, Nikam, Shah, Rutuja, Chavan. If Divya is there, then Divya. Then anybody else is willing to talk to me? What is the moment at the end of beam? At moment at A and moment at C. Hello, am I audible? Am I audible?
Zero.
Perfectly correct. Moment at the extreme ends of this beam is 0. So moment at A and moment at C is equals to 0. Already I have given over here. Moment at A is equals to moment at C is equals to 0. But I wish to identify the value of RA and RC, RA and RB. So let us have a summation of Fy. RA plus RB minus W is equals to 0. So summation of Fy is equals to RA plus RB minus W is equals to 0. Clear? Upward, the forces moving upward positive and the forces moving downward is a negative. So RA plus RB minus W is equals to 0. So RA plus RB minus W is equals to 0. So we can write RA plus RB is equals to W. Now, in order to calculate RA and RB in terms of W, let us have a moment at A. So summation of moment at A is equals to 0. So clockwise movement is positive and anti-clockwise movement is negative. So starting from this, clockwise, W is going clockwise. So W into 800, 600 plus 200. So 800 W, 800 W minus 600 into RB. So 800 W minus 600 RB is equals to 0. Therefore, W becomes 800 W is equals to 600 RB. So the value of RB become 800 divided by 800 W divided by 600. That is 4W by 3. But if RB is equals to 4W by 3 and RA plus RB is equals to W, from this equation we can have the value of RA is equals to W minus 4W by 3. So minus W by 3 is the value of RA. So we have the RB as a 4W by 3 and the value for RB is equals to RB is equals to 4W by 3 and RA is equals to minus W by 3. So we have the two different reactions, RA and RB we have calculated. Okay. Up till now, any doubt, query? What we have done? We have just applied the equilibrium condition. Summation of Fy is equals to 0 and we have calculated the moment about point A in order to identify the value of RA and RB. Clear? Up till now, any doubt, query? Up till now, any doubt, query? Up till now, any doubt, query? Shaha, Rushikesh,
No, sir.
Rushikesh, Kalyani, Rutuja, Kalyani, Rutuja, Rushikesh, Nikam. आहात का तिथे सुमेध सुमेध जोगदान.
Yes, sir.
Okay. So we have the value of RB and we have the value of RA. Now once we do have the value of RB and RA, let us find the value of moment at B. So moment at B is equals to RB into 600. RB into 600. So RA into 600, sorry, RA into 600. So value of RA is equals to minus W by 3. So it is minus W by 3 into 600. It would be 200 W. Right now, just what I have done, I have calculated the value of RA, RB and the amount of moment acting at point B. We have what we have calculated till time. In first case, we have calculated the centroid, that is X bar and Y bar, location of centroid, X bar and Y bar we have calculated. In second case, we have identified the moments, moment of inertia. In third case, what we have done, we have identified the value of RA, RB and the moment acting at point B. Now, moving onwards for the stress calculation. Hold a second. Now, the stress calculation. We are moving to the stress calculation. We have the formula, bending stress formula. M by I is equals to sigma by Y. We have to put the values only. Okay. M by I is equals to sigma by Y is equals to E by R. So M is nothing but the maximum moment. I just right now you have calculated 116.89. IXX. Sigma C and sigma T both are given to you from the simulated triangle. Simulated triangle means the diagram that I have shown to you. Though the diagram is like the diagram is here. Now let's move. Let me show you the diagram. Let me show you the diagram YC by T. This is the diagram that I required. This is the diagram. Okay. The diagram is saying that sigma C upon YC is equal to sigma T upon YT. Sigma C upon YC is equals to sigma T upon YT. That is a simulated triangle. So let's put the value of sigma C YC and sigma T YT. So sigma C is equals to, sigma C is given to you, how much it is? 100 MPa. YC we don't know. Sigma T is given 150. So we have to calculate the YC and YT. So can anybody tell me how to calculate the value of YC and YT? If I know the Y bar, can I calculate the value of YC and YT? If I know the value of Y bar, can I calculate the value of YC and YT? Yes, I do. Y bar, YC plus YT is equals to total length. YC plus YT is equal to total length. So how much total length? 20 plus 200 plus 240 plus 30, 270 is the total length. Y bar is equals to how much? We have calculated Y bar. Y bar is equals to 99.7. So this is which beam? This is the simply supported beam. Simply supported beam. When the simply supported beam is subjected to loading, top layer is subjected to compression, bottom layer is subjected to tension. So YT is equals to Y bar. So I guess YT is equals to, so simply supported beam is there. Simply supported beam is there. Simply supported beam with overhang. Simply supported beam all bending says okay. So simply supported beam with overhang. So it is overhang is given to you, na. So once this beam is bent, so it bent like a cantilever. In that case, what happens? The top layer is subjected to tension and bottom layer is subjected to a compression. So in that case, bottom layer means Y bar is equals to YC. So it is 99.37. And the total length minus this is equals to YT. So we have the YC, we have the YT. So we have to just put that value into the equations. So YC upon sigma C upon YC and sigma T upon sigma C upon YC and sigma T upon YT. So 100 is given to you, YC is nothing but Y bar, sigma T is given to you, sigma T is given to you, and YT is equals to 170. Now here we are going to check the safety. So in between YC and YT, the 100 is minimum value and sigma T is 150, means sigma C is 100 and sigma T is equals to 150. So at minimum load, what would be the probable maximum value of the sigma T that we have to identify? In that case, we are keeping sigma T as unknown quantity and we will be identifying the value of sigma T. What does that mean? When the compressive stress of 100 MPa is induced, the corresponding value of the tensile stress is 171. But what is the limiting tensile stress? That is 150 is given, which is less than the induced values. That is why we are taking the minimum value, that is 150 MPa is not the safe. So that is 170 is exceeds. So we have to go for the maximum value of the tensile stress, that is 150 MPa. Are you getting my point or not? इथे काय केलंय लक्षात घ्या. सिग्मा सी आणि सिग्मा टी पैकी जो लहान आहे, ज्या वेळेस या स्ट्रक्चरल मेंबर मध्ये 100 MPa एवढा कॉम्प्रेसिव्ह स्ट्रेस इंड्यूस होतो, त्याच वेळेस करस्पॉन्डिंग व्हॅल्यू आपण शोधली सिग्मा टी ची. जी आली आहे 171 171.69 बट दॅट इज ग्रेटर दॅन 150. त्याच्यामुळे जो काही सेक्शन आहे तो अनसेफ तयार होतो. तो जो आहे तो सेक्शन जो आहे तो अनसेफ तयार होतो. त्याच्यामुळे आपण जे काही डिझायनिंग करणार आहोत ते डिझायनिंग आपण 150 टेन्साईल स्ट्रेस कन्सिडर करून कॅल्क्युलेशन्स करू. म्हणून m अपॉन i इज इक्वल टू सिग्मा बाय y. m अपॉन i इज इक्वल टू सिग्मा बाय y. या केसमध्ये मला सिग्मा टी ची जी व्हॅल्यू आहे ती घ्यायची आहे 150. लेट अस गो फॉर द कॅल्क्युलेशन. Let us go for the calculation. M by I is equals to sigma by y. M is equals to maximum moment is given, maximum moment that we have just calculated 200. Here we have calculated. Yes, this is maximum moment is 200. Then Ixx we have calculated Ixx1 plus Ixx2 and so on. Sigma c is given 100 at the time. Yc is equals to 99 point something. We have to put all the corresponding value in that equation and we have to identify the value of W. The case number 1. The case number 2, we have to put the value of sigma t is equals to 150. M should be the same, I should be the same. Sigma t 150 and yt will be 170.625. And in that case, we have to identify the value of W. So here it is, the value for W is 158.150, W is equals to 588.125 kilonewton, and here it is 514.03 kilonewton. So the minimum value of the W is a safe value. The minimum value of the W is a safe value. We have to calculate the value of W, and the minimum value of W is a 514 kilonewton is the safe value. It is that much easy. Is there any doubt for this session? You can skip this part. You can skip this part too, but just for the cross verification, I have given this the calculation of W based on the sigma c. Once here the section is fail 171.69, so we have to go for the calculation with respect to 150 tensile stress only. So once you go with this, so it is very clear that the maximum loading will be the less than that, so it is the safe value. Up till now, any doubt, query? If anybody is having any doubt, query, please ask me. Shah.
No, sir.
Let me check who is there. Om, Rushikesh, Rutuja, Sumit, Vaibhav, Vilas, Vikas, Fotangre. Any doubt, query? Any doubt, query?
No, sir.
Okay, great. Rutuja,
No, sir.
good. So I'll share this presentation with you. No worry. So you just don't need to write it down. Okay. Moving onward for the next numerical. A beam having a channel section. The unit, the question would be like this: a beam having a channel section, as shown in the figure, subjected to bending moment about x-axis. Calculate the thickness T of the channel bending stress in order that the top and the bottom of the beam will be in the ratio of 7:3. Consider the beam as a simply supported beam. So what you have to do, the first agenda for you is to calculate, and you have to tell me the centroid, that is x bar and y bar, and then you have to tell me the Ixx. This is the homework for you. In the next lecture, I'll ask you what you have done, what you have calculated. Okay. So today I'm going to stop over here. In the next lecture, I will ask you about x bar, y bar, and moment of inertia. Thank you so much. If anybody is willing to ask me something, you may can ask. And if you wish to leave the session, you
Sir.
please.
Sir, can I get recording of this lecture?
Yes. I'll upload this on my YouTube channel. I'll share the link with you. You'll be definitely have the recording. No issue.
Yes.
Anybody is having any doubt, query?